This video we're going to talk about some definitions that are going to kind of lay the groundwork for the rest of the course. So the first one is a relation. A relation is a set of ordered pairs. So an example of a relation would be like the ordered pair x comma y. That's a relation. That's all there is to it. The domain is the relation. The domain of a relation is the set of all first coordinates. So that first coordinate there, those are the x's. So I think of them as my x's. The domain are the x's. Okay? The range of the relation is the set of all second coordinates. So the set of all second coordinates, those are my y's. Okay? Those are the y's. So the range, those are the y's. Okay? The range is also kind of thought of as the value. Okay, what is the value of the function? That's the range, that's the y value. The x is thought of as the where. Okay, so where is it? It's the location. Okay, so where, this is the input and this is the output. The range is the output. I plug in a value x and it outputs a value y. Okay, so it's independent versus dependent. Now, this definition here is one in which we'll use every day for the rest of the class. This is a definition of a function. All right, we're going to be dealing with functions for the remainder of the course. So a function is a special type of relation in which each x in the domain is paired with exactly one y. Okay, each x goes to exactly one y. Okay, so a function is a relation in which no two ordered pairs have the same first coordinate, meaning you can't have an xy where it's like 3 comma 2, so 3 goes to 2, but then also 3 goes to 4. You can't have that. That's a no-no. Okay, what you could have though is like 3 goes to 2 and then maybe 4 goes to 5 or something. Okay, so those are different first coordinates there going to different things. All right, now if a relation can be graphed in the Cartesian plane, the relation is a function if and only if, okay, this works both ways, there's no vertical line that passes through it more than once. And this is called the vertical line test. Okay, so to actually prove that a function is a function is kind of difficult to do mathematically. It's beyond the scope of the class. So what we do is we draw a pretty little picture and we say, okay, does this graph right here pass the vertical line test? Well, I look and I say, okay, every vertical line I draw, it looks like it only passes through the graph in one spot. So yes, it's a function. Okay, so that's the idea of the vertical line test. All right, so what we're going to do is we're going to take some graphs and we're going to determine, are these graphs, do they make a function or are they just a relation? Okay, so that's kind of your introduction. Those are your definitions.